Hi, welcome to section 10.9, circumference and arc length. Our homework is going to be on page 501 to 502, 4 to 5, 9, 13, and 14. Now, with this video lesson, there's not going to be too much except for examples. We already know how to find the circumference of a circle, and we know how to find the arc length, which links with circumference. So we're actually just going to get started with examples, and this should be a pretty short lesson. So here's our first example. We have a picture of a track, kind of like the track that we have here at Tinley. And we want to find the length of fencing needed to surround the track. So here we go. Let's talk about this for a second. What we have here are our straightaways. In the middle here we have a rectangle. It has length 50. Its sides are going to be sides of 12. And here we have two semicircles that are going to be bound by a diameter. If we were to combine those two semicircles, we'd end up with one whole circle. And we want to have the distance around that whole circle, which is going to be our circumference. So here we go. Let's find the length of the fencing, in other words, the perimeter that would wrap around. So if we have 50 on that side, that means that we're going to have 50 on this side as well. Now, we have the length around here, which is half of the circumference, half of the distance around. And our circumference formula is either going to be 2 times the radius times pi, or the diameter times pi. Here we have a diameter, so let's use the diameter formula. Now, since it's a semicircle, it's going to be 1/2 the diameter times pi. So we have 6 pi here, and since we have the exact same semicircle on this side, 6 pi here. Now, unless it says round to the nearest tenth, you want to leave things in terms of pi. 50 plus 50 is going to be 100. 6 pi plus 6 pi is going to give us plus 12 pi. And that's going to be the amount of fencing that we needed in order to surround. Okay, so here's actually our last example. We have David rides his bike 2 miles on a nice day. If he has 18-inch tires on his bike, how many revolutions did his tires make? Alright, let's press pause, and let's kind of make a strategy for what we want to do here. Alright, so the first thing that I notice here I'm going to highlight. I notice that he's riding 2 miles, and he has 18-inch tires. So first and foremost, our units aren't matching up here. Second thing, they want to know how many revolutions that we're making. When you think about the revolution, that's actually going to be when the wheel is going to go all the way around, which would be what? If you said circumference, that's absolutely perfect. So here's what I'm going to end up doing here. First thing that I want to do is I want to try and convert my miles into inches. Now, how many feet are in a mile? It's 5,280 feet in each mile. So here we go. Multiply out 5,280 by 2, and that's 10,560 feet. Now, we can either convert 18 inches into feet, or we can convert 10,560 feet into inches. The choice is yours. I'm actually going to convert the inches into feet, otherwise I'm talking about a whole lot of inches. If we have 18 inches, and we want to convert that to feet, whenever we're going to a smaller unit, we want to multiply. Whenever we're going to a bigger unit, inches to feet, we want to divide. There's 12 inches in every foot. So that gives me 1.5 foot. Feet, foot. What am I doing? So here we go. How many revolutions did the tire make? Well, here's what we got here. He has 18-inch tires, which means that's going to be our span across our diameter. So the diameter's length is going to be 1.5 feet. Now, we want to find out how many times the circumference is going to happen to give us our overall distance. So every time we make a single rotation, we have a point that starts there and wrap around. That's considered to be one rotation or one revolution. So let's find out what the circumference is, which is the distance around. Circumference formula again is going to be your diameter times pi. So here's what we want to do. 1.5 pi is going to be our total circumference. We want to find out how many of those is going to fit into 10,560. So with our calculator, we're going to divide out 10,560 divided by, let's throw this in a parenthesis, 1.5 pi. And let's type that in. And that's going to end up giving me 2,240.9 revolutions. Should we round that up or down? A revolution is going to be one total wrapping around. I would round that up to approximately 2241 revolutions. So here's the answers to our homework. Again, not many problems. We got 4, 5, 9, 13, and 14. If you have any questions about things in the video, please make sure you bring them to class tomorrow. And as always, have a good one.